Hello, welcome to our Unity 101 videos. I'm Abdullah. In our last video, we installed Unity as well as Visual Studio, we created a small cube within Unity, we got familiar with the user interface, and created a script, and we just started scripting. In this video, I'm going to talk more about GameObjects, about components within Unity, about the basic structure of a C# script within Unity, and maybe do a little bit of debugging. So let's get started. Every game object has a transform component where you can access its position, its rotation, and its scale. The checkbox up here enable and disables the game object. The checkboxes next to the components will enable and disable those components specifically. You can change the values of the components directly from the inspector. For example, I can change the scale to 2. But what is a component really? It's just a C# script that inherits from MonoBehaviour. MonoBehaviour includes things like the transform component that we talked about earlier. Unity also calls some methods within MonoBehaviour periodically, like the start method and the update method. When you create a new MonoBehaviour using Visual Studio, you can see the skeleton of these methods ready for you to override. When using the Unity game engine, we usually don't use concepts like a constructor. Instead, we use the start function, which gets invoked after a constructor. Unity needs to do some things under the hood before we can start using a game object. The update function, on the other hand, is a loop, and it will keep looping as long as the game object is enabled in the scene. Unity will call the update method every time it renders a frame on the screen. Unity will try to call the update method as frequently as possible depending on the resources of your machine. Now let's do some coding. Remember that transform that I was talking about earlier? To access that component from within Visual Studio, we can just type transform, then dot, and we can see all the members of the transform component here. We can see the position, the rotation, as well as the scale. So how do we expose these class members to the Unity editor? When creating a public variable within a MonoBehaviour, the Unity editor can directly assign and read that variable. Let's create a vector 3 called edit rotation. If you go to the inspector in Unity now, we can see the vector 3 started showing up under the rotating cube component. Just like the transform, we can edit the values directly from the inspector. Now let's rotate that cube. We can start by just typing transform. We can find a function here called rotate that takes in a vector 3, then rotates the game object by that amount. Let's put in the public variable we created earlier. Because we have this in the update function, this will rotate the game object for every frame that is being drawn on the screen. Now let's go back to Unity and press the play button. Now let's start changing the value of the y-axis of the vector. Let's put it something like 2. And that will make the cube rotate by the amount of 2 per frame. After we stop the game, you'll notice that the value of the vector went back to its original value. To keep the changes persistent, you need to change the values before you press the play button. Changing the values while the game is running is very useful if you want to experiment with things that you don't want to be saved. For example, if we want to change the values of the y-axis to something astronomical, then we can do that, and we can have some weird side effects, like the cube looking like it's actually going a lot slower. Oh, science. So just play around and try different things and see how the cube rotates for you. So what other MonoBehaviour methods we can use? Unity calls those messages. Luckily, Visual Studio has a simple way to find them and add them to your script. Just right-click anywhere in your script, go to Implement Unity Messages, and you'll see a list of all the Unity messages you can implement. Just check next to the ones you want to implement and press OK. I'm just going to add the fixed update method as well as the onCollisionEnter method and press OK. Another really useful tool is the debug.log method. You can pass it any variable you have in the class. I'm going to pass it the position vector that we have in our transform. Now let's go back to Unity and press on that console tab that we can see in the bottom. And let's run the game. And now we can see the value of the position vector in the console. This is very useful if you want to debug and know the state of your code inside of the Unity editor. This method will probably be your best friend. You can even just pass it a string. This will act like a marker for you in different parts of your code. So there you have it. Now you're a lot more familiar with GameObjects and how to modify them using C# scripts. Next time, how about we take some input from a keyboard and then modify the GameObjects using C# that way. See you in the next one.